Linear relation and rate of change. Ruby started 40 meters away from the motion sensor and walked towards it at a speed of 0.4 meters per second. Let's first think about it. Let's say here we have the motion sensor, right? And let's say this is the horizontal path on which Ruby is walking. So Ruby started 40 meters away. So that means, let us say she started at this point, and this point is 40 meters away. So this is 40 meters from the motion sensor, right? And walked towards it at a speed of 0.4 meters per second. And let's say now she starts walking from here at the speed of 0.4, this is 0.4 meters per second. That means every second she is approaching 0.4 meters. So with time, this distance between the motion sensor and Ruby is going to decrease. So whenever you are approaching, you will take speed as, or rate of change as, negative. Okay, so this is the concept which I want you to understand, and then we will answer the question. The question is, find her distance from the motion sensor after 1 minute. Now 1 minute means what? 1 minute means 60 seconds, correct? So that means after 60 seconds, find her distance from motion sensor. So initially it is 40, correct? So you can write your equation and then also find. So equation is y. You want to find the value y from the motion sensor, and the rate is 0.4 meters per second. Since you are approaching, we should write this as negative, right? So we are negative 0.4 x, and initial distance was 40 plus 40. So this is the equation, right? Now here, if you put x as 60 seconds, you will get your answer, correct? That is one way of calculating. Let's do it. So basically what we are saying is, final distance will be minus 0.4 times 60 plus 40. Okay, so 4 times 6 is 24. So we have minus 24 plus 40. Let me write minus 24 plus 40. Correct? And that gives you the answer. So 40 minus 24. Correct? So you get 6 and 16. So that is the distance, final distance. So that becomes your answer in meters. So that's the way to do it. Another way to think about it is kind of like this. How much distance will Ruby cover in 60 seconds? So every second she is covering 0.4 meters. So in 60 seconds, it will be 60 times 0.4, which is 24. So she'll be closer by 24. So this distance will reduce from 40 to 40 minus 24. So you get 40 minus 24, which is same as 16 meters, correct? So you can approach it in this fashion. Also, that's good for understanding, correct? So what we did here, we actually applied linear relation. Linear relation, the equation is of the form of y equals to mx plus b, right? Where b is your initial value of 40. M is slope or speed or rate of change. Now since you are approaching, we'll put negative sign with this rate of change. And so we get our equation. The equation is minus 0.4x plus 40 for initial distance. I hope you understand completely both the methods, how to do it, correct? Now part B is, when will she be 4 meters away from the motion sensor, correct? So one way, let's adopt this approach. If you want to be 4 meters away, then the distance covered should be 40 minus 4, that is 36, right? She should get enough time to walk 36 meters, right? Now the speed is 0.4, therefore the time will be 36 divided by 0.4, and that gives you the answer. So 36 divided by 0.4 gives us 90 seconds. 90 seconds. 90 seconds means 1.5 minutes, right? 1.5 minutes, right? So that is the answer we get by solving like this. General method, which I prefer, writing the equation. When will she be 4 meters away from the motion sensor? That means y is 4. So let me write 4 equals to minus 0.4x plus 40, correct? Now we'll solve for x. So we'll bring this term is negative on that side, so 0.4x equals to 40 minus 4, which is 36. And now we can solve for x. X is equals to 36 divided by 0.4, which is 36 divided by 0.4, 90, right? And this unit is in seconds. Seconds. And therefore, our answer here is either you can write in seconds, that is 90 seconds, or you can write 90 is 60 plus 30, right? Or divide by 60, 1.5 minutes, right? So both are right answers, correct? So that is how we are going to solve these types of questions, right? So it is rearranging your formula and getting the answer. That is for part B. For part A, it is a constant rate of change, since Ruby is walking at a constant rate of 4 meters per second. Negative sign is because she is approaching or coming closer to motion sensor. So we get our equation, y equals to minus 4 minus 0.4x plus initial distance. And using this equation, we can answer both the questions. Okay, I hope you understand. Thank you and all the best.